Hello guys, welcome back to Logical Notion. So the topic for today's lecture is recursion. Okay, so let's begin. But before proceeding, let's first discuss in a very layman's language that what is recursion. So anyone from the programming background can simply answer the recursion in very simple terms. That what is recursion? So recursion is nothing but repeating itself again and again to obtain certain solution. Okay, so now let me add few more things to it. So recursion is nothing but breaking down a complex problem into smaller parts unless we achieve certain solution to that complex problem. Okay, so now you will ask that why we are breaking this complex problem. See, there are certain scenarios where the problem is very complex. So if we like start solving that problem right away, so we will get the solution to it, but it will be time consuming and the solution to it will be very complex. So to reduce that complexity, recursion is done. Recursion will break that complex problem into smaller parts. Okay, and then by breaking down into the smaller parts, it will first of all try to solve each and every small part of that bigger problem, and then when all the smaller parts of that bigger problem is resolved, then all those small solutions will be compiled up, and that compilation of all the solutions will give us the solution for that big complex problem. So this is actually the actual definition of the recursion which I just told you. So recursion is nothing but a technique used to resolve the complex problem in which a function calls itself again and again until that particular complex problem is resolved and the solution to that problem is achieved. Okay, so now what is recursion? If we dig deep into it, we just discussed what is the definition of recursion. So now let's understand what is recursion, how it works. So recursion is a process which follows the stack mechanism. And what is the stack mechanism? If you guys might have watched my previous videos, in the very first video I discussed that what are the different types of data structures. So in that data structure we discussed a stack type of data structure. And what is this stack data structure? In the stack data structure, it follows last in first out. Okay, if you don't have any idea about it, let me just tell it with an example. So consider you are having a cardboard a box. Okay, a box. So if you are set to place certain books into it, how will you place it? You will place the first book, then the second book over it, then the third book over both of these two. So now if you require the very first book which you put into the box, so how will you get it? First of all, you will remove the very topmost book, then you will remove the second last book, then you will get the desired, that is the last book which you wanted. Okay, so this is how the stack works. It will also it also works on the same principle, that is last in first out. By last in first out I means the book which went at the very last will be the first one to come out. Okay, so that is the stack mechanism. Similarly, the recursion follows the same mechanism of stack. Okay, and how this thing is being followed, because in the recursion what happens, before the complete function has arrived to its final solution, again a function call is made, and then that function call again calls itself. Okay, let me repeat it. So what is recursion? Recursion is nothing but a function which tries to compute a solution, but before it arrives to a particular solution, it calls itself again. And why is it calling itself again? It's doing nothing but it's just breaking a complex problem into smaller parts. Okay, and at the very end all these small parts are compiled together to give the complete solution. So whenever a function call is made, the previous answer from which it made a function call, that will be stored in a stack. Okay, and when all these smaller parts are calculated, so we will take out each result from the stack one by one, add it together and give the complete answer. So you will understand it more clearly through an example. Okay, so now let's discuss about some examples of recursion. Okay, the very simplest example is factorial. Now what is a factorial? Factorial is nothing but okay, let's understand in this way. Say suppose we are having a positive number 5, so we need to calculate its factorial. And what is factorial? Factorial is nothing but the product of all the numbers less than or equal to the given number. Okay, so if we need to calculate the factorial for 5, so how we will calculate it? We will multiply 1 into 2 into 3 into 4 into 5, and then the result of all these products will give us the factorial of that given number. Okay, so we have a very simple algorithm for this factorial, which you can see here, that if the value for n is equals to 1, then we will simply return 1, else if the value is other than 1, then we will simply calculate the answer value, that is nothing but n into factorial of n minus 1. Now if you carefully observe, in the second step, the factorial n minus 1 and our main function name, that is factorial n, they both are same. The only difference is n and n minus 1. Okay, so before the algorithm comes to the third point, that is the exit point, it again calls itself, okay, but provide some other parameters to it. Okay, so we will learn more about it in coming few minutes. Okay, so this is the very simplest example, but among the other few examples we have Fibonacci series and the Tower of Hanoi. But for this lecture, to keep it very simple, we will discuss the factorial example here. Okay, so now let's begin with it. So far we have learned that what is recursion, but now let's understand it with an example. So for the example, I will be considering the factorial algorithm which we just saw in the previous slide. Okay, so let's begin. In this factorial algorithm, we will be using two variables. The first one is this n and the other one is this answer. Okay, and the value for n will be considered here as 5, and for each and every loop we will be storing our value in the answer variable. Okay, so let's begin. Our complete algorithm is divided into two sections. The first one is for the first point and the other part is the second point. So for value of, when the value of n will be 1, then we will go inside the first point, or else for any other value of n we will always go in the second point. Okay, so let's start. So now initially, when our value for n is 5, we will calculate our answer as n into factorial of n minus 1. So what is the value of n? It is nothing but 5 into factorial of n minus 1, that is 4. Now it is very important to notice here that this particular statement, if you see, this is nothing but our function name. The only difference is that it is n minus 1. So what value we will be feeding it here, that is 5 minus 1, that is 4. So this 4 value will be fed into this, and this function will be called again. Okay, and when this function will be called, it will again go to the first point. It will again go to the first point. Here value of n is 4 now. Okay, let me just write it down here. So the value of n is 4 now, but since our first point will only check for the n value when it is 1, so it won't go in the first point. Again we will come back to the second point. Again in the second point we will calculate the answer, where again it is n into factorial n minus 1, that is nothing but 4 into n minus 1, that is 3. Okay, so again now 3 will be fed into this, and again a function call will be made. Since now again our value for n is nothing but 3, so it won't again not go into the first step, it will again go to the second step, and again we will compute the value for answer. So now it will be 3 into factorial of n minus 1, that is 3 into 2. So now our value for n has become 2. So now 2 will be fed into this, and again a function call will be made. It will again call itself, and now again we won't go into the first step since our value for n is not equal to 1. So we will again come back to the second step, and we will again calculate the value for answer. So the answer will now become 2 into n minus factorial of n minus 1, that is nothing but 1. Okay, so now this point is again very important. Now our value of n has become 1. Okay, so now when 1 will be fed into this, a function call will again be made, and now we will go to the first step. Now since like I said in the earlier in the beginning also, that for only n equals to 1 we will be going inside the first point. So now since our value for n has now become 1, so we will go inside the first point and it will return us 1. Okay, so let me just write it down here. N value has become 1, and while we go inside the 1, so it will return us 1. And do remember that it is the first time that we are returning some value. Okay, earlier we were only stuck at this point, that is this answer statement. Okay, we didn't went to the return answer statement. Okay, we are returning the value for the first time. So now this has returned some value, that is 1. Okay, now remember, okay, have a close look at here. In the fourth point we were still calculating this answers value. Okay, you remember that we haven't calculated our second value, our answers value, but while we were calculating a function call, because of this one and this statement, let me just mark it with some other color. Okay, so because of this statement, this particular statement, factorial n minus 1, a function call was made and we will jump to the next step. Okay, so now since our function has returned something, okay, so now this bracket thing will be replaced by the value that the function has returned. So it will be 2 into 1, that is 2. Okay, similarly, like we just saw how we went to the fourth step, we went it through the third step, because we were calculating the answers value in the third, but before we can calculate, a function call was made, due to which we went to the fourth step. Okay, and what our fourth step has given us? Fourth step has given us this second, that is 2 value. So this 2 value will be sent back to the third step and it will be calculated, the answer value will now be calculated. Okay, and 3 into 2. Okay, so 3 into 2 will be 6 now. Similarly, this 6 will be fed into the second step, and our answer value will now become in the second step is 4 into 6, that is 24, and this 24 will again be sent to the first step, that is nothing but 5 into 24, and the final value will become 120. Since we don't have any further trace backing, so our final value is 120. This 120 value will be stored in the answer, okay, this 120 will be stored in the answer, and then our function will finally return this value for this answer, and then we jump to the third statement and we exit. So we just saw that how inside a function we make a function call. Let me just show you. We were inside this function. Okay, we were inside this function, and inside this function only we made another call to a function, and that function is it's nothing but itself. So before it can complete its process, we again call that same function, just to break down the complex problem into simpler parts, because if you see, our bigger value for n was 5 initially, but then we break it down into 4, and then we break it down into 3, and then 2, and then 1. Okay, until unless our, so basically the aim of recursion is that until unless we break a complex problem into very simpler problems, we keep on iterating. Okay, and when we reach to the very basic statement for that particular problem, then we start summing up, or then we start adding those answers to give the answer to a complete problem. So through this example we understood that what is recursion and how this recursion concept is implemented. Although this is a very simple and this is a very simplest example of the factorial, but just to get the concept of this recursion, I have included this very simple example so that all of you guys can understand it in very simple terms. Okay, so now we will learn that what are the advantages and when we disadvantages, and when should we use and when should we not use this recursion method. Okay, so let's proceed to that section. Okay, so now we have a good understanding of what is recursion and how it works. So let's discuss what are the disadvantages of using a recursion. Okay, so let me just, before proceeding, let me just tell you one point here, that all the demerits or disadvantages of recursion will revolve around two basic points, that is the space, how much space it takes, and how much time it takes to execute. Okay, so keeping in mind, let's just begin with the disadvantages. So the very first disadvantage states that we can compute the answers for the mathematical problems very easily with the recursion, but again we have to compensate with the time and space. Okay, second point also says the same story, that it is not efficient in the terms of time and space complexity, and the third point is very crucial. So what this disadvantage is trying to tell us is that recursion it is good practice to use the recursion, but we should be very careful while using the recursion. Why so? Because if we have not implemented the recursion process carefully and we don't have a proper condition for the recursion to stop, it will go on continuously, and at a point of time our memory will be occupied and our system will crash. Okay, so it's very crucial for us to put a break condition in the recursion, so that basically not a break condition, we should design a recursion function in such a way that it should work efficiently, okay, and it should have a break condition in it. Okay, so the last point also says the same story, that it is basically a slower because it has to maintain a stack. Okay, like I earlier told that recursion uses the stack mechanism, so to maintain that stack also it requires some space and some time to process all those things. So these are basically the 4 disadvantages for the recursion. Okay, so now let's move on to like what are the advantages and why or when should we use the recursion. Okay, so when should we use a recursion? When we have a very complex problem. Okay, so recursion is basically used when we know that okay, we have a problem and we can achieve to its solution, but that solution may require some repetitive steps. Okay, and we already know these things, that computation of this may require some repetitive things, so that can be easily done with the recursion, because recursion is nothing but repeating itself. Okay, so those things can be easily done with recursion. Now coming to the second point, so it says that every problem, like basically the tree structure problems. So if a tree structure problem, by seeing the tree, if we see that okay, this problem is representing a very complex tree structure, okay, so for those problems recursion is a very good answer to it. But if the tree structure for that particular problem is quite simpler, so I would suggest that we can avoid this recursion here and we can simply go with the iterative process, that it for loops or while loops and all those things. Okay, and coming to the last point, so iterative solutions. Why the recursion is preferred more than the iterative solution? Because iterative solutions always include more variables, and to understand those functioning of those variables, because each time a loop goes through it, so value for all those temporary variables are changed. Okay, so that's why it sometimes becomes very complex to understand those problems, even like so suppose we are dealing with a very complex problem. Okay, so in that scenarios it becomes very difficult to debug the program if any issue or any error occurs in our program. Okay, so in that case recursion offers us some advantage over there. Okay, so that was all about the recursion in this lecture. So I hope you guys have got some idea that what is recursion and how is it implemented, what are the demerits, and when to use the recursion. Okay, so I hope you guys get some knowledge about recursion from this lecture. I hope you guys like this video. Okay, thanks for watching.